Very good. Then, good afternoon. My name is Fabrizio Del Maffeo. I'm the CEO and co-founder of Axelera AI. Axelera AI is a company that started only 4 years ago in Europe, and today we have more than 260 people, very high qualified people. We did 4 chips in 4 years. Then each year we do a new chip. Our product in the market is called Metis. It's available. You can buy it online. You can buy it clearly from Innodisk. Thank you so much for inviting me, by the way, Ray. The company then is fast growing, a lot of customers worldwide, and I will show you later where we sell, how we sell, and so forth. But let's have a look at artificial intelligence. Just to recap where we are today in the market. AI showed the largest adoption in the world, right? No technology like AI got this kind of adoption. We reached, ChatGPT reached 100 million of users in weeks. But the most important, if you see on the right side, there is a very strong adoption from companies. Companies are now deploying AI, which is a great news. And the other great news is that companies are making money. You see, ChatGPT clearly is making revenue. Anthropic is, OpenAI, Anthropic is making revenue. But also other companies which are using the API, like Lovable, which is one of the largest startups now in terms of adoption, are making millions of revenue. Essentially, an AI-based company, a company using AI or developing solution in AI, is growing 4.5 times faster than a standard software company. And if you look also at the distribution of neural network, if you look also at the players on the market, there are more and more players, right? And the performance of these players are very, very close. When we started, there was only ChatGPT, there was only OpenAI. Today, you have plenty of solutions. And more important for us, which are in the embedded, it is a very small market where many companies cannot afford to buy network or to develop networks. You can see that thanks probably for DeepSeek and then for many other companies who followed, you can see today that you can get open source models performing extremely well. Open source models are growing fast and are almost catching up with the frontier models. This is a great news. It means that in a few years, we can have just a model, take it and run it without paying. If you look about the market leader, still OpenAI, still ChatGPT, and OpenAI is a market leader not only for models, but also in terms of revenue generation and hype in artificial intelligence. You see in the picture on the left that OpenAI is at the center of whatever it's artificial intelligence with NVIDIA, with AMD, with all the other players. Not yet with Axelera, not yet. And more impressive is the deployment, right, of artificial intelligence in data center. We are building everywhere data center. And these two pictures are shocking. If you look on the left side, you have the Oracle OpenAI Stargate project in the United States. This is just the first phase, and you see how big it is. And on the right side, you see Meta, the project of Meta, the Hyperion project. Basically, it's like Manhattan, right? They are building up a city, but it's not a city, it's a data center. Well, are we going in this direction? Are we going to constantly build new building, new data center? I think that the market will be adjusted in future. Things will change. And we see in which direction things may change. Smaller AI models are becoming more and more efficient and better in performance. This is a very important message. Last week, Samsung released a model which is extremely small, but is a very great reasoning model. Small means edge. Small models means models that can run in edge devices. Then all of you that are interested in edge devices, and today you are looking at and thinking, what can I do in the future? Actually, here is the answer. The answer is that more model will run in any single device, and you will have a reasoning model everywhere. This will enable robotics at scale. And you see that edge is growing. This chart is from last year. I was checking this morning. I could not update it, but actually there is an acceleration. We are moving from an expected 20 to 30% market growth year after year to more than 40%. Clearly, edge is the next big thing. We saw also in this picture, right? Jensen Huang, 10 years ago, delivered to Elon Musk the first AI server, and last week he delivered the first box PC for Edge AI. It's great. Yeah, clearly NVIDIA is my competitor, but I admire what they are doing, and it's also a big signal for all of you, for all of us, that Edge AI is coming. And it's coming, clearly we spoke about robotics, other presenters talked about robotics, but look here, these are the company doing robotics only in the United States. I show United States because you know better than myself China, which is clearly a large market, but even in the United States, if you see, it's impressive. More and more company popping up, designing robotics, probably is the next multi-trillion opportunity. It will take years for robotics to grow, but it's still a great opportunity. And, but besides robotics, there are plenty of other applications at the edge. I think that security, retail, industrial automation, defense markets, automotive, all of these markets are growing. And if you look what customer wants, what customer ask in this market, they want more and more compute. Compute density is a key. But they want also cost, low cost, because while I don't care the cost of GPU of OpenAI because I just pay the service, if I buy a computer, if I buy a desktop, I have to pay for it. And I want to pay as less as possible. Then price is essential if you want edge to scale. As well as efficiency, because many applications are either for harsh environment or power hungry. Then it's important to take in consideration compute density, efficiency, and cost efficiency. And in Axelera, we think we have solved this. We built up a platform starting from a new technology called digital in-memory computing. Essentially, we integrate the computing part inside the memory. It's a very unique technology, and we have also RISC-V technology. And integrating these two technology, we design chip, and with our partners, like Innodisk, we design boards, and we give a very powerful software stack to all of you to design software. As a result of it, we have a complete product portfolio, here you can see, and the most important thing is that we outperform all our competitors. The value proposition of Axelera is very simple. Performance, high performance, low cost, low power consumption. We always win when it's a matter of throughput per dollar, throughput per watts. And here we removed the name of the competitors, but it's public. You can check on our website, you can check on the web. Essentially, we outperform all the players in our market segment at delivering high performance at the fraction of the cost. Besides performance, we have clearly a useful software stack. Software is always evolving. A company like us has more software engineers than hardware engineers because software is essential. Each day there are new networks, each day there are new requests from customer, and our software reach a good maturity, is in GitLab. You can download it, you can change it if you want. And as you can see here, we have a very powerful accelerator which works with any kind of CPU technology. This is our approach. We want just accelerate. And now we'll give you a little bit of overview of a real case. This is a real customer, real project in deployment. This is close by. This is a case, a customer in Indonesia. They're using our technology to check the quality in the kitchen, what people are doing, and so on. And this show that essentially we can deliver extremely high throughput, again, due to the fact that our chip is a multi-core and high performance. And a customer can connect multiple cameras to solve this problem, tracking people, tracking what they are doing, tracking the product. Another interesting product example is this, is a real example, is a self-checkout system when essentially we are monitoring if people are stealing or not goods. You know, this is a self-checkout system. People can just steal the goods, go away, and we are monitoring this. Another one that's interesting that I could not show the original one. We show a simulation. The original one is for weapon detection, to detect if people has a gun, but you can use it also to detect if people are picking up something, for example, fruit in a grocery shop. And this is another example that you can build up in a few minutes if you buy our hardware. All of this is available in the SDK. Another example is for quality control. This is the bread and butter, I would say. All of you probably are involved in industrial application, industrial computing, and in this example you can see that essentially with one chip we are streaming to one chip multiple video and solving multiple problems using one chip, one solution, one board that costs a couple of $100. Then we're talking about this with 200 TOPS. Another interesting example is also in agriculture. This is an example where essentially we proved to reduce the latency. Essentially, it was a very difficult problem. We had to detect the quality of seeds and count them in 2 milliseconds. 2 milliseconds. And we could make it, essentially. We won against, as you can see, a market leader in this. Another example that is becoming more and more popular is for smart city. The problem of smart city, when you have to monitor large area, is that you need extremely high resolution frame and cameras, and you need a very powerful way to process data. And here you can see that with our SDK, essentially we take a very high resolution image, 8K, we break down in small images, and what we can do is essentially detect each single person. This is very important for security. And when you detect the person, you can start to detect really the face if you want, if you have the capability also to zoom in. Then extremely important for surveillance in public area. Last example, all of this with the first generation of our chip Metis. You can do all of this. It's in the SDK, very simple. And this is another example is LLM. Our first chip, when we designed the chip, LLMs were not around, but we designed in a good way, and the chip supports also LLMs. This is an example. Again, it comes in the SDK. You can just deploy an LLMs at very low cost and run it in our chip. Okay, but now let's switch gear. Yesterday we announced a new product, and this is my first presentation about new product because it was announced yesterday night. And I'm happy to be here to introduce you to Europa. Europa is the new product that we announced yesterday night. It's an evolution of Metis. It's a very powerful solution. It's a 630 TOPS AI accelerator, which then can be combined with any other CPU. And compared to the first generation, is designed to run generative AI network at the edge. But it's also designed to do pre- and post-processing, decoding everything inside the chip. Essentially, the chip is a multi-core solution. You have 8 core, extremely powerful core. You have a lot of memory on board. You have decoding. You have a cluster of pre- and post-processing RISC-V cores, which we developed over the last 3 years. And all of these allow you to deliver extremely high throughput, again, at a fraction of power consumption and cost. Here are the solutions that we are going to launch early next year about the chip. Essentially, it will be available in Q2, this solution. And these two boards, one will be one chip and the other multi-chip. We are talking about a board that costs a fraction of the cost of any other solution, in the sense that we are talking way below $1,000, this kind of solution, which are 600 TOPS, way below, almost half of it, I would say. Then, again, our approach is simple. We want to democratize AI. We want to give, in the hands of you, a very powerful accelerator at low cost, low power consumption. As you can see, it's 50 TOPS, 50 watts, but it's 630 TOPS, right? Then extremely powerful. And here you can see the first projection that we have in terms of for LLMs. Essentially, with this chip, you start to run LLMs of 20 billion, even 30 billion. You can combine multiple chips. Then it becomes a very powerful solution and very cost-effective solution. And when you come also to application like standard computer vision, here you can do really whatever you want. We are talking about you can connect 32, 64 cameras and run at a very high resolution, very sophisticated network. Then essentially you can imagine you can build up with a very low cost MVR and do whatever you want. Do any kind of analytics directly on chip. Pre and post processing, everything at a fraction of power consumption and cost. And on top of it, you can clearly also enable new things, because AI is evolving, neural networks are evolving, we are entering into this agentic era, I would say, of AI, where computers start to reason and take decisions. And to do so, you need a new network, vision, language, action network, right? Or agents. You need a very sophisticated network for segmentation, like that can be even 8 billion parameters. You need a lot of computing. All of this today is possible, but you need to spend €1,000. You need to spend $2,000, $3,000, $4,000, sorry. We can do this at a fraction of cost. Then we want really to have our technology everywhere and enable anything your imagination wants to build. Thank you so much. Then if you want to reach out, you have my details. You have also details of our web shop. You have details of where to download the software, where you find information. We have a community. Then you can go to our community. If you want to buy a sample, you can buy it online. You can buy from our reseller. Essentially, we want to really give the chance to any of you to test and try our technology and give us a feedback if you don't like it. It's very important also the negative feedback, because at least we can improve. Thank you so much for your time. I hope you enjoyed the presentation and enjoy the rest of your day.
Thank you, Fabrizio, for your insight, for sharing. And please visit it.